So, hello guys. I am right now trying to show how exactly the two models of DFT, one using a looping method and a matrix based, could be used to find a DFT of a particular signal. Sir has already mentioned once that he actually uses matrix, he actually prefers matrix based method in order to make it time efficient. So before I actually go for showing you the memory issues that might be related to matrix based method, I will first show why exactly he prefers the matrix based method. So here is a file which has the name analysis of DFT. Now now this will be this and this file would be using three functions apart from already the inbuilt functions like signal synthesis, DFT loop, and this DFT loop is basically using a looping method of for DFT manipulation, and this DFT is basically a matrix based DFT manipulation. And signal synthesis is used for creating signals. Actually there are four types of signals normally that we use. Either it could be impulse response or unit step, ramp, or continuous function, that is sinusoidals. So I'll be showing the DFTs. I can't actually show you the mechanism of the DFT loop and DFT, basically the codes, because the assignment is still not done. So let's proceed. So we have a signal. First of all, this signal is supposed to have 100 sample points, and it's a type 2. Type 2 is basically a unit step function here. So it will be plotting DFT using looping method and matrix method. Let me change this once. Let me make it 3 3. Okay, 2 3, and let me include subplot 1 3 1 stem uh, n slash x r title signal in time domain. This is I have included this statement to show you that what's the signal being created. Okay, so let's run the program. So here you can see it's a unit step function, and its DFT is being shown here. This is a looping based method, and this is the matrix based method. Okay, so now you can see that I am actually displaying some commands. That is the time taken for loop based DFT, the time taken for matrix based DFT, and the correlation between the DFT. The correlation is to actually check whether the DFT created between the two techniques are similar or not. So if we see here, the time take let me make some adjustment. A equals to 0. Yeah, now you can see it. So the time taken for loop based DFT is 0.013509, and the matrix based is 0.06. You can see that the matrix based is extremely time efficient compared to the loop based, and the correlation is 1. So they are extremely similar. Now let's uh, change the number of inputs, number of samples basically. Let's make it this 100,000. Now let's see how much time it takes. So this is my command prompt. It's still not coming, taking time, taking more time. Still waiting. Still waiting. So now the DFTs have been generated, but it took 43 seconds for loop based DFT. On the other, matrix based DFT was almost generated instantly, like 1 second, but the loop based method used 43 seconds. So it actually shows that how inefficient the loop based method could be. And again, if you're interested to know whether DFT is similar or not in both the cases, here we have the correlation between the DFT using different methods is still 1. And it's a simple correlation, not cross correlation, so you can be sure of it that the signals are pretty much similar. So now, before I go for showing the memory issue for this much value, I would have to stop the signal DFT created by the loop based method. Otherwise it would take minutes also, possibly minutes. We don't have that time. So let's comment this. We don't require the subplot created by this DFT looping method. Let's not get worried about the coefficient. And yeah, let's first raise it to, like, this is, let's just keep it this much, 10 less than, it's 1/10 of the critical value that I got. So now let's run it. Let's see how much time it took to, oh, we already have the problem. So it's already showing that it's the array exceeds maximum array size preference. So actually I think that I got that value for some other function, though with unit step only we got the memory issue. Let's see if it can generate, somehow it can generate uh, wait a moment. Let's see if it can generate a figure for unit impulse. Okay, it's showing the issue even out here. So we actually got the memory issues even for the unit step as well as the unit impulse. It will be same case for others also, because the matrix required size is basically the same, almost 149 GB, and it's not allowing me to do the analysis over such a huge memory. So I guess I have proven my point out here that the DFT using matrix based may be more time efficient compared to the looping method, but you will face memory issues as you increase the number of samples. Thank you.